Within no time we've seen out how easy it is. So but now we know that at a y value of 5 something is there. Either there is an asymptote there at a y value of 5, or there could be a hole there, okay, at a y value of 5. Something is going on. So now let's see how we're going to do it. So remember that we now want to find to do the sketch. So f of x is equal to x squared minus x minus 6 all over x minus 3. I mean, we can sketch this anytime. Let's do the sketch. This is another easy one. So what is it? We know that the moment I see this power is bigger, the highest power on x, this is the highest power, it's a 2. This because here it's a 1 and here there's no x, it's a 0. So the highest power on x is a 2. Here the highest power on x is a 1. So I can see that the one on the top is bigger than the one on the bottom. Okay? Which means that there cannot be a horizontal asymptote. There is a slant asymptote because it's bigger than the one on the bottom by a 1, right? So I'm going to say, how do I find that slant asymptote? TBH, there's a faster way to find that slant asymptote, and that is just by factorizing. Okay, you can do the factorization and you can find the slant asymptote. The slant asymptote would be the remainder. If you can factorize and cancel, then the remainder would be your slant asymptote. So I can say, I know that I can do that because I've done it here. I know that I can do that. From here, I'll be able to know my hole. And this answer that remains will be my slant asymptote. So I can do it again here. So I know that this was x plus 2 multiplying x minus 3 on top here. And here we have an x minus 3. So we know that they then canceled and canceled. So you can have f of x equal to x plus 2. So you can say, therefore, there is a slant asymptote. There is a slant asymptote, because if you divide and you get something as your solution, that is the slant asymptote. Okay, whether there was a remainder or not. So in here there is no remainder. We happen to know that if there is a remainder, we can't divide this way. We have to do long division. Okay, so therefore there is a slant asymptote at y equal to x plus 2. And guess what? This y equal to x plus 2 happens to be the graph itself. And you can say, and there is a hole. You can say, let this thing that canceled, x minus 3, be equal to 0. Say, let x minus 3 be equal to 0. You say x equal to 3. And you can say, therefore here, there is, no, first of all, we have x equal to 3. And let's put f of x again. F of x will now be equal to this, x plus 2, this smaller thing. We use the smaller thing now. And we put the 3. We say f of 3. This gives me 3 plus 2, which is going to be 5. You can now say, therefore, there is a hole at 3, 5. Okay? Because it's x equal to 3, which means that the x coordinate is obviously 3. And the solution you get here is the y coordinate, which is 5. So we know that there is a hole there. Now, we can do the two intercepts and it would be done. So the intercept, this is going to be a straight line, people, because we have this as the graph, the simplified version of the graph. The simplified version and the original version are the same. Okay, don't ever think that by simplifying you can't then take this new graph. No, you can, but just make sure that you don't forget the hole. The only difference between this new version, which we get after canceling the factors, is that the original one has a hole. Okay, so here there's a hole. Now we know the hole, and we know that there's a slant asymptote. In other words, we know the line. Now we do one more thing, which is just we need one more point. So you can say x-intercept or y-intercept. Okay, so let's do for y-intercept. Okay, you put it again. Put the f of x again. Put f of x is equal to x plus 2. Then now say for y-intercept. You can say for y-intercept. You'd now say let x equal to 0. So you'd now say f of 0 is just going to be 0 plus 2, which is going to be 2, okay? And the answer will be 2. So you can say that the y-intercept, you can say therefore, the y-intercept, you can put the y-intercept is at, we know that x is 0, so 0, y will be 2, okay? That is the y-intercept. You can use this. It's enough. Sorry for this. You can use this to sketch your graph. These two are enough to sketch your graph. The y-intercept and the whatever, and the whole, okay? Because the whole is a point. But you can now just say, put it again, say f of x is equal to x plus 2. Then you can just say for x-intercept, you can say for x-intercept, you now say let y be 0, which is f of x be 0, okay? Where there is f of x, you are now putting 0. So 0 is equal to x plus 2. You take it to the other side, minus 2 is equal to x. So x is equal to negative 2. So you can say, therefore, the x-intercept, you can say, therefore, the x-intercept is at the point, x negative 2, so negative 2 comma y is 0. So it's negative 2 comma 0. Now you can do the sketch. What is the important thing? Let's put all the important things for this sketch. What are the important things for this sketch? So this is the y-axis, and here I have the x-axis. Right. Now let's put the x-intercept is at negative 2 comma 0. So it's going to be here, negative 2. So this is going to be the x-intercept. The y-intercept is going to be at, 0 comma 2. So 0 in the x and 2 in the y, which is like here. And then you can have your whole. So let's join them with a straight line. Okay, a straight line which joins them. I mean, you can do your graph properly and you do your scales nicely. This would be, you can just join with the ruler. Then you already have your y is equal to, or your f of x is equal to, you put this expanded version, x squared minus x minus 6 over x minus 3. That's the graph. And you know that there is a hole, so you must be able to put the hole. Where is the hole? There is a hole at 3 comma 5. Okay, let's put this nicely. 3 comma 5. So 3 in the x. So we go in the x, we go to 3 and we go to 5. So if we go up, it should meet at 5. So this is 5. And there is a hole here. So there is a hole, and it goes like this and it goes like that. And we can see that we have a hole at 3 comma 5. What is the y coordinate of that hole? 5. Is it the same as your limit? Was my limit equal to 5? Let's see. Yes, my limit was 5. So you can say, since the hole is at y value, a y value of 5, then you can now say, therefore, the limit as x approaches 3 of x squared minus x minus 6 all over x minus 3 is equal to 5. Here we have proved again, okay? We have just written this longer way, but we've proved it because we look at the y value of whatever is going on. There has to be something going on at a y value of 5. The function should not be defined there, okay? The function should not be defined there. And we have, it's not defined. There is a hole. So that means that this is a limit for sure. And you'd be done. You would have proved. That's it. Goodbye for now.